In today's lecture, we are going to learn some fundamental ideas of the chapter differential equations. Till last lecture, we have learned the concepts of area under curve. We have solved lots of questions, but now it's on to you. You are supposed to practice at least around 50 to 100 questions to master that chapter. Now, area under curve is highly scoring chapter. So, in every year in mains and in also in advance, you will get at least one question, and guess what? These questions are naturally solvable. If you approach with a right idea and right solving techniques, you can solve all questions of area under curve in any exam, may it be mains or advance or any other exam. Now, coming to differential equations. Differential equations is also very highly important chapter. In fact, your future is full of differential equations. Now, you might have seen that in physics and chemistry also, that almost in every chapter there is differential equation involved. So, your future in science and engineering will also start with differential equations. In fact, every concept that you learn will start from differential equation, and from there concepts are generally built. So, differential equation is very important for your future. That is the reason why every year there are questions on differential equations. Now, this is one chapter where they cannot ignore to give questions, they always give questions, and also this chapter is again scoring chapter because all questions are naturally easy type. Okay. So, let us get into the chapter now. So, first we need to understand what exactly is differential equation. So, in simple terms, we can say that any equation involving differential terms means derivatives. So, any equation involving derivatives or differential terms is called as the differential equation. Now, there could be in a differential equation, there could be variables x, variable y and derivatives of y with respect to x, or in other words we can say that there would be dependent variable, independent variable and also derivative of the dependent variable with respect to independent variable in the differential equation, apart from the other constants and other things. Okay. So, typically in our 11th-12th standard, dependent variable means it is the y and independent variable means x. Derivative of dependent variable with respect to independent variable could be y dash, first derivative or second derivative or third derivative and so on. Okay. So, this is typically the definition of differential equation. Now, your differential equation need not be in terms of a polynomial. Polynomial form may not be possible all the time. There could be differential equations where polynomial terms are not possible, okay, but they are all differential equations. Let us look at some samples of differential equations along with the basic fundamental concept of order and degree. Okay. First, let us learn this, then we will look at the samples. So, order is defined as the highest order of the derivative involved. So, there could be first derivative, second derivative, third derivative. So, whichever is the highest order derivative, that will give the order. Now, what is the degree of differential equation? If the differential equation is put in a polynomial form, if it is possible, then the term with the highest derivative, whatever is the power of that term, that will become the degree of the differential equation. So, it is possible that in some cases differential equation is converted into polynomial form, so degree will exist, but if differential equation is not possible to be converted into a polynomial form, then degree may not exist. So, there can be cases where degree may exist and degree may not exist, but if degree exists, it must be a natural number. It cannot be 1.5 or 2.3, degree must be natural number, because definitely we are not talking about the 0 degree differential equation. If derivative term has degree 0, that means differential equation does not exist. Okay. So, now here we have understood what is an order of differential equation, what is degree. Now, let us look at some samples of differential equations. Suppose let us say we have one differential equation here. Here second derivative of y with respect to x is involved. So, this is second order derivative and here there is first order derivative. Out of these two derivatives, which is the highest order derivative? Second order derivative is the highest one, which is this term. So, order of this differential equation becomes 2. Okay. Now, let us look at the degree. To understand degree, we have to convert this equation into a polynomial form. Polynomial form means all the derivative terms. Derivative terms here are basically y double dash and y dash. These terms must be having whole numbers as the powers. Only then it can be treated as a polynomial equation. But here first derivative has square root. So, what we do is we keep this on one side and we push the others to the other side and we square them both sides. Now, when we square and simplify, we got rid of root terms, but if you look at the term of the second derivative, the degree has increased now. Now, that degree is the overall degree of the differential equation. So, even though it looks like the degree looks like 1 here, actual degree of this differential equation is 2. So, degree is 2 for this equation. Let us look at the second equation. So, here there is 2 by 3 in the power. So, we know that even though there is an equation here, it does not look like a polynomial. We have to convert that into polynomial to get the degree. But to get the order, we can just look at it and comment about the order. So, for this equation, order is basically 3 because there is third order derivative involved. Now, to get this into polynomial form, we may have to cube this. So, we take x plus y to the other side and we cube it on both sides to get rid of the rational powers. So, this will give us the degree to be equal to 2. Okay. So, there is a slight mistake here, it must be 3 here. Okay. Now, further, if we look at this third equation, there is third derivative here d cube y by dx cube and there is first derivative but in the power of e. Now, there is no way of converting this equation into polynomial form, it is not possible. So, hence degree of this equation does not exist, but order exists. What is the order of this differential equation? Order is basically 3 here because third derivative is involved, but degree is not defined. Now, you may be thinking of applying the series expansion of e power x here, but if you apply the series expansion, now all the terms here will go till infinity. So, that way we cannot actually get one strictly finite polynomial. Our polynomial equations of differential equations must contain finite number of terms, that is important. If it does not have finite number of terms, then we cannot go for the idea of degree. Okay. So, I hope this is clear to you. So, when derivatives get into transcendental equations or implicit equations where we cannot get polynomial form, then we can say that the differential equation does not have any degree. Okay. So, this is one typical idea of what is a differential equation, what is order, what is degree. Okay. Come on, make a note of this. Okay. Now, can we proceed to the next idea? So, here we have understood what is a differential equation. Now, let us look at how to form a differential equation. We can form differential equation from the given equations. So, I will take you through two approaches. One is the algebraic approach, other is the geometric approach. So, let us look at algebraic approach. Let us say I take one algebraic equation. Okay. So, for instance, let me take one equation, let us say x equal to k into y plus y square. Let us say I take one random equation here, and this is the algebraic form of the equation. We don't know what this represents on geometry, we will see that little later. Now looking at this, there is one value which we don't know, which is the k, which is the parameter. So sometimes k is also called as arbitrary constant, but here it is called as the parameter. Now to get the differential equation of this curve, this equation, what we do is we differentiate it and eliminate the parameter. So that means, suppose if I differentiate it here, what do I get? Derivative of x is 1 with respect to x, and derivative of y is y dash. Here derivative of y square is 2y into y dash. Now our goal is to eliminate the parameter. How do we eliminate the parameter k here? By solving for k from one equation and substituting in the other. So from second, if I get k will come out to be 1 minus 2y y dash by y dash. I can directly substitute it here. So what do I get? I get x equal to 1 minus 2y y dash divided by y dash plus y square. Okay. So now when we simplify this, what is the form that we are getting? X into y dash equal to 1 minus 2y y dash plus y square, or if we take everything to one side, we will get x plus 2y into y dash minus y square minus 1 equal to 0. See how does it look like? It looks like a polynomial equation. So this is in the standard form of the differential equation. Now here, what is the highest order derivative involved? Only first order derivative is involved. So order is 1. What about the degree of the differential equation? Because the y dash term has only degree 1, so degree is also 1. Okay, so this is the basic idea of forming a differential equation. Now I have explained the method first. Now let us read the method. What is it? Differentiate and eliminate all parameters involved. But there are some nitty-gritties here. In every method there are definitely plus and minus, pros and cons, nitty-gritties. We have to understand all of them. Suppose let us say our equation has only one parameter. To eliminate the parameter, we need actually two equations. You recall our ideas of elimination of theta from trigonometry, solving for values in algebra. So if you recall all of them, you will understand the idea that to eliminate one parameter, we need two equations. You can also compare our coordinate geometry ideas. Okay. Now to eliminate two parameters, we need three equations. Now if one equation is given, to get two more equations, we need to differentiate the given equation two more times. So that means second derivative will get involved. So if there are two parameters, there will be second derivative. If there are three parameters, there will be third derivative. So in a way we can say that order of the differential equation is nothing but the number of parameters involved in the equation. So now these number of parameters also must be minimized. Okay, we should be looking for the minimum number of the independent parameters. For example, so if we have let us say y equal to ax, so this becomes one equation, there is only one parameter here. But if we are going to write this as ax equal to by, so here it may look like there are two parameters, but we can of course divide with any constant here and convert this into one single parameter kx equal to y. So effectively there is only one independent parameter here. So that is why we should be looking for the independent parameters. Okay. So the logic here is that the degree of the order of the differential equation is equal to the total number of independent parameters involved. Okay. So that is what we have understood from this idea. So we can say that order of the differential equation is the total number of independent parameters involved. Okay. Can we move on now to the next idea? There is one more statement here, but ignore this statement. We will learn this statement after a while, because here I have already used the word family of curves, but I am going to explain the family of curves in the next page. So here you can understand that this is the converse of this statement. If a differential equation has order n, now ignore about the family of curves, Okay, so solving it, we should be getting one equation where we have n parameters. Okay, if order is n, there must be n independent parameters. If independent parameters is n, then order must be n. So this is two-way statement. So this is like double implies. If one happens, other happens, A implies B, B implies A. Okay. Now let's look at the geometric meaning of this differential equation. Okay. But before that, we will form few differential equation, try to understand, or let's try to mix all of them. It's better that way. Let me mix. Okay. So there is this geometric interpretation. We want to understand geometric interpretation. Let's look at one example. Here, do not read this statement. First, try to understand the explanation that I am giving. After that, you can read the statement. So this equation represents circle with center at origin and radius as a units. Now, if we look at the geometry of these circles, if we fix A, there will be one circle which is fixed, but if I vary A, that means if I am varying radius, but center is already fixed to be origin. So now when I vary A, I am going to get many circles having common center at the origin, but radius different. We can call all those circles as the family of circles having common center or family of concentric circles. So it's a family. Now if I differentiate this and eliminate A, what do I get? Suppose let's say I differentiate directly here. So I get 2x plus 2y y dash equal to 0. The parameter got eliminated directly. So if I cancel out 2 and write it like this, it becomes the differential equation. We can also verify the order here. Order is only 1 because there is only one parameter. So now this is the way I started from the geometry and went till the differential equation. Now let's go back in the reverse direction. If we start from the differential equation, by integrating or somehow let's say we have solved it and got an equation like this. So what is this equation representing? It is basically representing family of curves. So every differential equation represents a family of curves on 2D plane. Now what kind of curves are these? That may depend on the equation. Now before we go further for the second example, let me explain you another idea here. So here we have eliminated a square directly by implicit differentiation. You can also go for the explicit differentiation, but then it may take little more longer steps to eliminate the parameter. Let's look at this process in the next example. Suppose let's say I have one curve here, y square equal to 4x. It is going to be a parabola. Now a is a constant, generally that's what we take in the coordinate geometry. Suppose let's say I take a to be a parameter, that means it is changing. So it is going to give me too many parabolas. So if a is positive, I will get all parabolas of this orientation, and if a is negative, I may get all parabolas of this orientation. So basically here this equation is representing family of parabolas having vertex at origin and axis as the x-axis. Now to get the differential equation of this family, we have to eliminate the parameter. So there are two ways of doing it. One is directly going for the differentiation. So what do I get here? 2y y dash equal to 4a. Now we got two equations. One equation that is the given one, second equation that is the derived one. We want to eliminate the parameter, so try to solve for 4a and try to put it there. So we get 2y y dash equal to y square by x. Now assuming that y is not equal to 0, I am going to get 2y dash equal to y by x. So this becomes our differential equation representing this family. Now here also I went for directly implicit differentiation. I can also go for explicit differentiation, okay, or somewhat like this, y square by x equal to 4a. Here if I differentiate directly, what do I get? I have to apply quotient rule here. So, x into 2y dash minus y square into 1 divided by x square, this must be 0 because derivative of 4a is 0. Now, here assuming that y is not equal to 0 and x is also not equal to 0, we can get 2x y dash minus y equal to 0, which is going to give us y dash equal to y by 2x, which is same as the earlier equation. Okay. So, now the process that you will decide to use will depend on you, but you can somehow eliminate the parameters and get the equation. So, here we have basically understood that every differential equation represents a family on 2D plane. Okay. Family means family of curves. Every family of curves has a parameter. Okay. So, come on, make a note of this. This page also. Okay. Now, let us look at a different example. This example may strike a node of your physics knowledge. Okay. So, there is a family of curves given. So, here it is already given that it is a family of curves, and we have to form the differential equation of this family. So, how do we do that? We have to differentiate and eliminate the parameters. What are the parameters here? A and B are given as the parameters, K is a constant. If I differentiate this, what do I get? Let us say I differentiate once with respect to x. So, I will be getting A into K into cos kx minus B into K into sin kx. Of course, I have used the chain rule here. Now, if I differentiate one more time, I will be getting a k square into here sin kx but with one minus sign, and here also minus b k square into cos kx. Now, if I take minus k square common, I am basically getting y here. So, basically this equation is becoming y double dash equal to minus k square into y. So, that means the differential equation is going to have order 2, and what is the degree of this differential equation? It is 1. Okay. Now, if you look at this, isn't this a familiar equation? This equation actually represents simple harmonic motion. In fact, remember that if acceleration is proportional to negative of the displacement, then it is going to be simple harmonic motion. Acceleration is proportional to the negative of the displacement, it is going to be simple harmonic motion. Okay. It is always true. So, this is one typical example of the physics. Suppose in future if you are learning the oscillations, damped oscillations or any other, let us say you are studying aerospace engineering and you are talking about the wings vibrations, or let us say you are doing mechanical engineering, you want to talk about the vibrations of the bike or car, you will be using this equation. Okay. You will be starting your problem with the differential equation and you will be solving it. So, that is why it is important to learn differential equations chapter. In fact, when you go to IIT, your first year courses will be fully on differential equations and matrices, determinants and vector algebra. Okay. Okay. So, here we have understood how to form differential equation. Now, while forming the differential equation, it is one sweet accident that when we went for the double derivative, it got eliminated automatically, both A and B got eliminated automatically. But that is not the case in all questions, you may have to do some algebra in many questions. Okay. Come on, make a note of this. Okay. So, now we will move on to the next idea, that is understanding the solution of DE. Now, when we have one differential equation, what exactly is the meaning of the differential equation? Algebraically, we are trying to find out the original equation from where we have derived the differential equation. Geometrically, we are looking for the family of the curves which are represented by that differential equation. Now, in other words, what is the function which is actually satisfying that differential equation? We are looking for that function. So, in a way we can also say that we are looking for the function, or we are looking for the family of curves, or we are looking for one algebraic equation. Okay. So, that is exactly the point that you have to understand when it comes to solutions. So, a differential equation which is of the order n, if we solve it, we will be getting one family of curves having n parameters. That is exactly the point that we have skipped earlier. Now, it is typically a function. Now, when I am writing function, do not go for the strict definition of the function that one pre-image should have only one image. Now, do not go for that, because if you get solution as a circle, circle is not a function. Okay. But you need to get one relation in terms of x and y. Okay. Now, to understand this, let us take one very simple and basic example. Suppose let us say y dash equal to 3 is given as differential equation. This could be the most simplest form of differential equation. Now, I want to find out all equations which will satisfy this, or I want to find out all functions which will satisfy this. So, how do we do that? What is the function for which the derivative is 3? It will be 3x plus some constant. So, if I integrate this, I will get 3x plus one constant c. This c is called as arbitrary constant. Okay. What is the meaning of arbitrary? It means random. Okay. So, that also means that c could be randomly chosen by the user, by you or by anyone. If we fix c, we may get one fixed solution, but if we vary c, we are going to get many solutions. For example, here if I fix c to be 1, I will get one straight line. If I fix c to be 2, I will get another straight line. So, I can take any real number for c. So, that means I am going to get lot of lines, in fact infinite lines with slope 3 units. So, we can say that this equation represents family of straight lines which are parallel. Okay. Now, that is exactly the statement that we have written here. Solution typically represents the family of curves. Now, here look at this c, which is also arbitrary constant, is the actual parameter here. So, when we eliminated this, we got first derivative. So, order is 1. Okay. So, we have understood what exactly is the geometric meaning of this solution. Now, let us look at this solution part in little more depth. We got the solution which is y equal to 3x plus c. So, here c is actually random parameter, we call it as arbitrary constant. In fact, in IIT Bombay there is also this students lingo means language. If a student is behaving randomly, if someone is not thinking at all, someone is behaving very randomly, people call him as arbit admi. Okay. So, that is just a slang to insult people, to say that he is very random, he does not think logically. Okay. So, he is very arbit. Okay. So, now this is an arbitrary constant. Because c can be varied and many solutions can be obtained, it is actually called as the general solution, because it is going to cover up all possible cases. If I fix c, let us say I put c equal to 2 or something, then I am going to get y equal to 3x plus 2. So, it is only one special case of that general solution, it becomes the particular solution. Now, we can obtain the particular solution by substituting some conditions given in the question. For example, if it is geometry, in the question it may be mentioned that the curve is passing through a point 2, 3. So, that means we will get, when we put 2, 3, we will get that constant c. Okay. Or we can also use other ideas like at t equal to 0 displacement is only 3 units. So, when we put those conditions we will get the arbitrary constants, then it becomes the particular solution. So, here we have understood what is particular solution, what is general solution. Okay. Now, let us move on to the other ideas. This is some terminology that you need to know before we proceed. So, PDE means partial differential equations. That means if partial derivatives are involved, it is called as partial differential equation and it is not in your syllabus. You know the partial derivatives, for example this dou f by dou x and dou f by dou y. These are basically partial derivatives. So, differential equations involving partial derivatives are not in your syllabus, but you will study this in engineering first year. Okay. Now, ODE, ordinary differential equations. If differential equation involves ordinary derivatives, it is called as ordinary differential equation. Now, what are these ordinary derivatives? These are the derivatives that we have been handling. So, y dash dy by dx, d square y by dx square, all these are the ordinary derivatives. So, this is exactly what we are studying in 11th and 12th standard. And LDE means linear differential equation. So, you know the meaning of linear equation. All the variables involved must be having degree 1, that is the meaning of simple linear equation. But when it comes to linear differential equation, what are your variables? These are your variables y, y dash, y double dash, y triple dash, whatever are the derivatives that are involved. These are your primary variables. For example, let us say you get one function here into y double dash plus g of x into y dash plus some h of x into y equal to 0 or some other function of x. Okay. Now, this is still treated as linear equation in differential equations, because if you look at these y double dash, y dash, y, these three terms are having only degree 1. So, it is a linear equation in differential equations. So, here this f of x, g of x, h of x, o of x, these may be having any degree or any kind of functions. It can have tan x, e power x, any function, log x also. But it does not matter, because our main focus is on only y and derivatives of y. So, basically we are talking about the dependent variable here. Okay. So, this way we can understand what is the meaning of linear differential equation. Okay. So, in our syllabus linear differential equation is there, ODE is there, but PDE is not there. And in linear differential equations also only first order is there, that means only y dash is involved. So, we will not get higher order derivatives at your standard. Okay. But if at all you face any question by mistake or something, if you get any question in any exam, remember that you have learned only linear differential equations of first order. So, you can convert the problem into first order and solve it. Okay. So, that is the main idea here. This is just to discuss the terminology with you. Okay. So, now can we move on to the next ideas? If you want, you can make a note of this. Okay, next. Now, let us look at how to solve the differential equation. So, till now we have understood what is differential equation, what is order, what is degree, what does it represent, how to form it, and what does it represent geometrically, algebraically, how to understand that representation, what is the solution, what does the solution represent, we have understood that. Now, let us look at how to solve the differential equation. So, the first and foremost and important and simple method is variables separable method. Now, if you look at the name itself, variables can be separated. The meaning of this method is in the name only. Variables can be separated and integrated. In general, to get the solution, integration is the only way. So, you have to integrate and get the solution. Now, what are the variables involved? In general, in 11th and 12th standard, the only variables that we are dealing with are x and y only. So, that means all terms of x must be taken to one side, all terms of y must be taken to the other side, and then we can integrate them separately, both LHS and RHS. That is the main idea of this method. So basically what is the process here? All terms involving a variable are grouped together before proceeding for the integration. This is the method of the integration. But when we are grouping, we should be grouping only one variable. If you are grouping all x terms, y should not be there in that group. Okay. So we have understood this. So after you group them, you will be getting somewhat these terms, f of x into dx equal to some g of y into dy. So all x terms will be on one side, all y terms will be on one side, then you can integrate. Okay. So you know how to do that. So this way we can complete the process, and this is the discussion of the method. Of course, we will see some examples. So there is one important note that you need to understand. So generally I keep saying this, that with every method there is one disclaimer, there is terms and conditions, when it could be applied and when not, and what are the general nature of those methods. So here this method typically consists of first order derivatives. So in your 11th and 12th standard, if you see any question based on variable separable, it will have mainly first order derivatives only. Okay. Now let us look at some examples of this. So with this you can understand that we have actually started solving the problems. So here there is x term in LHS, there is y term in RHS, and if you look at the RHS, there are x terms and y terms, both are combined. But what is the method of variable separable? We could be able to separate the variables. So here if I try to take all terms involving x common, so what is the term involving x here? E power x. If I take e power x common, I will get e power y plus y square into dy. And what is the LHS? LHS is dx. Now I will take all terms of x to LHS. So I will get e power minus x into dx is equal to e power y into dy plus y square into dy. Okay. Now we can integrate both sides separately. So I am just putting the integral sign. Now what is the integral of e power minus x? Of course it is minus e power minus x is equal to integral of e power y with respect to y is e power y only. Integral of y square with respect to y, it is y cube by 3. So can we say that this is the solution? This is one particular solution, but we need to always generalize the solution. So we have to put that integrating constant, which is also called as the arbitrary constant. Okay. So this is the solution of that equation. Now if you look at the overall approach of this method, whatever is the expression here, we should be able to separate that into two segments. One contains all terms of x, the other contains all terms of y, but that too in product. This is the important. When you are separating terms, they should be in terms of product, not in terms of summation or difference. So only if they are in terms of product, we can take them to the other side and solve them. So this is the important thing that you have to remember. Okay. Come on, make a note of this. Now let us look at few more cases. There is one form which is not exactly in the variable separable form, but we can separate them by reducing it to variable separable form using some manipulations or substitutions. For example, here if you notice, these terms, these two terms are actually looking like they are separated, but they are not. As I said in the earlier question, they should be separated in terms of the product, not in terms of the summation or difference. So this cannot be done using direct variables and separables. We have to use some kind of substitution or manipulation. So what I will do here is I will take x plus y equal to some other variable z or anything, that is your choice. Now when I differentiate this, I will be getting 1 plus y dash is equal to z dash. Z dash means derivative of z with respect to x. So for y dash I will put z dash minus 1 here. So z dash minus 1 is equal to z, this is in the RHS. Now if you notice, z dash equal to z plus 1. What is z dash? It is basically dz by dx. Now the variables could be separated. How do we separate them? We can write it as dz by z plus 1 is equal to just dx. Now we will integrate this both sides. What is the integral of the first term? It is ln of mod of z plus 1 is equal to, here we get x plus c. So we have basically solved the differential equation by using the substitution idea here. Now ideas may vary depending on the problem. Now let us look at this. This integrating constant, which is the arbitrary constant, it is actually getting added to x here. Suppose let us say I apply exponential power here. So what do we get? Mod of z plus 1 is equal to e raised to x into e raised to c. We can also write it as k into e raised to x. So here the arbitrary constant is multiplying, but here the arbitrary constant is adding. But it does not mean that these two solutions are different, they are actually same. Okay. So the values of c and k may be different, but they are representing the same family, because algebraically they have come from the same differential equation. Okay. So this way we can understand how to convert one differential equation into variable separable form. So with this we close the theory for today. Now we will solve problems. Okay. So let us look at one or two more examples. So there is one more equation here. This is actually very simple one. What you need to do here is to look at this and understand, is this possible to directly separate the variables here? If not, then collect the terms of similar kind and try to see if they can be separated. So I will just explain till we separate it. Okay. So we are getting basically y minus x into y dash is equal to ay square plus ay dash. If I collect all terms of y together, I will get y minus ay square equal to xy dash plus ay dash. So basically RHS is x plus a into y dash. Now y dash is nothing but dy by dx. So we can also write this as x plus a into dy by dx. Now let us collect all terms of y on one side and all terms of x on one side and see if it is possible or not. So we will get dx by x plus a here is equal to dy by y minus ay square. So now variables are separated, our half job is done. Now we have to integrate it. So till here the differential equation chapter comes, and after this it is the chapter of integration. So that means we have to integrate both sides. But if you look at LHS, it is very simple integration, but RHS is not that simple. We have to go for partial fractions there. So 1 by y minus ay square can be partially fractioned in two terms like this. So we need y to be cancelled here. So I will put e here. So y is cancelled. So basically we get dx by x plus a is equal to dy by y plus a into dy by 1 minus ay. Now we are going to integrate this both sides. So what do we get here? Ln of mod x plus a is equal to ln of mod y plus a into ln of mod 1 minus ay divided by minus a. So a may get cancelled, and there should be one integrating constant. I put it in the LHS, it does not matter. So this way we can proceed with solving differential equations. So here we may not directly see the variable separable form directly in the equation. we may have to do some manipulation or simplification. Okay. So, in fact, if you see any question in this chapter, the first method that you will be striking is the variable separable method. If that does not work out, then we will look at the other forms. Of course, we are learning that theory in the next lectures, subsequent lectures. Okay. Now, let us look at some interesting problems. So, here there is one question. What could be the idea here? I am not going to solve all questions. I will give ideas and give some questions for your homework. You need to solve them at your home and you need to post the response on the app. Okay. Whether you like the questions or you do not like the question, you got the answer or you do not get the answer, anything you can share on the app. Okay. So, here the idea is going to be that we will put x plus y equal to one variable z or t and then simplify this. Okay. So, this way you will be able to solve it, but you have to send the sign inverse to the other side to solve the question. Okay. So, let us take this as homework question. I am keeping some interesting questions in the reserve, so I am skipping these easy questions. Okay. Now, this is one interesting question. To solve this question, what we try to do is we try to collect the terms of same kind. How do we collect the terms of same kind? Here, if we notice, sin of x plus y term is actually repeating. So, that is actually giving me hint. So, what I will do is I will collect all terms of sin x plus y. So, if I take this common, what am I getting here? I am getting dx from the first term and dy from the second term. Okay, well and good. Now, let us look at the other terms. This term is cos x into tan y into dx, and the next term is sin x into sec square y into dy. This must be 0. Now, first term is already sorted out because we know that d of x plus y is nothing but dx plus dy. We already know this. So, if I take this x plus y as z, it becomes my dz. So, there is no issue with this term, but these two terms are little confusing. But if you look closely, derivative of sin x is cos x, derivative of tan y is sec square y. So, it is actually giving you some kind of hint. It is looking like f dash into g plus g into f dash, sorry, f dash into g plus f into g dash. It looks like product rule of derivatives. So, that is actually giving us hint. So, we will verify it. So, if I take d of sin x into tan y, what do we get? D of sin x, that means derivative of sin x is cos x into dx into tan y. That means we kept the tan y aside and differentiated only sin x. Now, let us keep the sin x away and differentiate only tan y. That is going to give us sec square y into dy. This also luckily got translated into one single term. So, how do we understand this? We understand this as sin of some, let us say, parameter, some variable t into dt. So, here t is basically x plus y, and what do we get here? We get d of sin x into tan y equal to 0. So, now when we integrate this, what do we get? Here we are going to get, what is the integral of sin x with respect to x? It is minus cos x. So, it is minus cos t, t is nothing but x plus y, plus here it is sin x into tan y and one integrating constant. So, this would be the solution of that differential equation. So, here also if you notice, this is not exactly this kind of variable separable. If you notice these examples, it is not exactly this kind. It is a little twisted problem, but if you notice, all variables of one kind are sorted out in one term, all variables of other kind are sorted out in other term. So, this is the idea that is most used in this chapter. Okay. Come on, make a note of this. Okay, so let's look at another problem. I think this is very easy problem. You can try doing this. The only trouble with this problem comes from the integration, not from the differential equation. Okay, so when you solve it using integration, you may take little more time. Let's look at another question. This is also easy. You can just take x cube common here and solve it directly. You can also take y cube common here, x cube common here. So that's an easy question. Let's look at this question also could be solved using x plus y equal to z or something. If you don't get, you let me know, I'll solve it, I'll solve this. Probably in the next lecture I'll try to solve this, but today I'll take one interesting question. Okay. Let me take this question. So, let's take this question. Find the curve passing through the point 0 comma minus 2. So, there is a condition given, that means we can always find the constant, such that the slope of the tangent at any point, on the curve is equal to the triple of the ordinates. That means, let us say if I take one random curve which is y equal to f of x. Let us say this is my random curve, and let us take one random point on this. Ideally, we can take the point as x comma y, but always taking point as x comma y will actually confuse you. So, let us take the point as h comma k. Okay. Now, if I differentiate this function, generally what is the derivative? Y dash equal to f dash of x. So, what will the derivative give us? Derivative will give us the slope of the tangent. So, that means at this point if I draw a tangent, the slope of this tangent will be nothing but k dash. Slope is nothing but k dash. What exactly is the meaning of k dash? It is the f dash of h. Okay. Now, what is the given condition? It says slope of the tangent is equal to the triple the ordinate. That means k dash must be equal to, what is the meaning of ordinate? Y coordinate, it must be equal to 3k. We have formed a differential equation based on the given data. Now, we want to solve it. Now, before we solve, after you get the finalized differential equation, replace h with x, k with y. So, basically it becomes y dash equal to 3y. Now, solve this using any method, because we have learned only one method till now. Let us apply the variable separable method here. So, dy by dx becomes 3 into y. So, we can also write this as dy by y is equal to 3 into dx. Now, when we integrate this both sides, we are going to get ln y equal to 3x plus c. So, which could also mean that y is equal to e power 3x into a constant k, which is the parameter. So, this is the solution, but we have to put the point. So, when we put 0 comma minus 2 in this equation, it must satisfy. So, putting 0 comma minus 2 will give us minus 2 equal to e power 0 into k, which means k is equal to minus 2. So, that means the final function becomes y equal to minus 2 into e raised to 3x. This becomes our equation of the curve. Now, till we got this arbitrary constant, it is still the general solution, but once if we put this condition, it becomes a particular solution. This is particular solution and this is the general solution. Okay. So, this way we can understand the process of solving and also the solution. Okay. So, in the next lecture we will start with the problems that we have left off with, and then we will proceed with learning new concepts and new ideas. Okay. So, I hope you guys are loving the lectures, and keep watching, keep learning, keep developing knowledge and problem solving skills. Okay. So, also take care of yourself, take precautions, always use sanitizer and be healthy. Okay. So, we will meet again in the next lecture. Until then, have a great learning day. Learning shall never stop.